So how do you use better passwords? So clearly we know that we are having problems with the passwords, right? When you use passwords, we surely have the problems, and we need to have a goal to eliminate this guessable passwords. That will be a primary objective. So still, when you're trying to avoid using guessable passwords, we should also allow the user to use the password which is easier for him to remember. That might be kept in mind while actually designing the password system. So what are the techniques that can be implemented for this is like you can go in for educating the users, and they can go for computer generated passwords. You can go for reactive password checking or proactive password checking. So these are means by which you can implement a password which are not guessable, and also it is easier for the users to remember. So what is proactive password checking? So here we have a rule enforcement plus a user advice, where we have 8 plus characters. There's a combination of upper, lower, and numeric characters, and also punctuations. It's a most widely used methods now, right? So when you actually design a policy, you can have like 8 characters minimum. Upper or lower characters can be used, and you can use numeric characters, uh, and also the punctuation, like it's a special character, and it may not be sufficient also, right? So even the hackers have a chance of hacking even if you use all these combinations. And you can use a password cracker, and also this might have some time and space issues. You can also go for Markov model, which generates some guessable password. Hence, we have to reject any password it might generate. And also, we can go for Bloom filter, which is used to build a table based on dictionary using hashes. And also, we have to check the desired password against this table. These are the means by which you can go in for the password checking. That's the proactive password checking. Next is the token authentication. So as I told you, like you can give some tokens to users so that they can use it for authentication purpose. So the object of user or object user possesses something to authenticate. Example, like you have embossed card, or a magnetic strip card, or a memory card, or a smart card. So type of cards used as tokens, we have already discussed. It's the embossed card, or the magnetic strips, or memory cards, or the smart cards. So the embossed cards are raised characters, which are having raised characters only on the front. And example is an old credit card, and a magnetic strip is like a magnetic bar on the back, characters on the front is a ATM card. The example is the ATM card, which is now being used. And next is a memory card, which is electronic, which is having an electronic memory inside. And its example is a prepaid phone card, like it's a SIM card, like similar to a SIM card. And we have the smart cards, which is of 2 types. One is the contact, and another one is the contactless. So the smart cards are having electronic memory and a processor inside. The example is a biometric ID card. So what is contact? So actually contact is you make a physical contact of the card with the device. So electrical contacts exposed on the surface, and contactless is a radio antenna embedded inside, which is like example is one is it's like a RFID card, so where you don't have any contact. This example is the library card which you use. So memory cards, like example is an ATM card, store but do not process the data. It stores but does not process any data. And it's a magnetic strip card, and it's an electronic card which is used alone for the physical access. You can use a pin along with it to authenticate the user, and we have some drawbacks also with this particular memory card. It needs a special reader when you want to use it, and when you use your ATM card, you need a pin number. Like if you lose the pin number, then you have some issues. And also we have a lot of user dissatisfaction, like unlike the bank ATM cards, like we have a lot of the complaints from the users. So what is a smart card? We discussed earlier. It's like a credit card, like it has its own processor, memory, I/O ports, and it has a ROM, EEPROM, and a RAM memory. Right. So all these make up a smart card. So this ROM, EEPROM, and RAM memory are part of memory of the smart card, along with the processor and the I/O ports. And also it executes protocol to authenticate with a reader or the computer. So we have the static, which is similar to the memory cards. We have the dynamic, with the password created every time and entered manually by user or electronically. Also we have the challenge response, that is the computer creates a random number and smart card provides its hash, which is similar to a public key. And also I have a USB dongles. So this is about the smart cards. So this is a small diagram which says how a smart card or the readers exchange smart card and the readers exchange the information. So maybe we need not go in detail into that, just it is given for your reference. So what is the biometric authentication? You know that nowadays we are prone to use this biometric devices. If you go to any offices, or if you go to any even universities or any other working places, we have this biometric authentication, which is the most primarily used way of authentication for the users. Like it's always unique. It's very difficult to manipulate this biometric way of authenticating the user. So you are you authenticate the user based on one of their physical characteristics. That is what you actually do. So we also take into consideration the cost and the accuracy. So which is more costly, which is less costly, and also which is more accurate and less accurate. When you see that the retina and the biometric, the finger recognition is equal, it's having like it's also accurate, and also the cost is affordable. So if you go to the iris one, it's very costly. But when you come to the hand recognition, or the finger recognition, or the face or the voice recognition, it's less costly, but the effectiveness is less. So this is a diagram which depicts how a biometric system actually works. So when the user keeps a finger, not a hand, a finger on the biometric device.